Good evening, ladies and gentlemen. Thank you in advance for the opportunity that have been given to me. Please allow me to introduce myself. My name is Chandra Swandewi from the Department of Biology Education, Universitas Pendidikan Indonesia. My team consists of myself, Hernawati, Trina Ekawati Tale, and Diah Kusumawati. Here, I will present our research entitled In Silico Study of the Interactions of Taurocolic Acid from eel, Anguilla bicolor, with angiotensin converting enzyme 2. Slide is okay. COVID-19 is caused by the SARS-CoV-2 virus. Until October 19th, 2021, based on WHO data, there have been around 240 million cases with around 4 million deaths. In this viral infection process, the receptor that plays an important role is angiotensin converting enzyme or angiotensin converting enzyme 2 or ACE2. ACE2 is expressed in several organs such as the heart, lungs, kidneys, and intestines. The majority of the ACE2 is found in the lungs because it is expressed by the type 2 alveoli as much as 83%, causing the lungs to be an organ that is very susceptible to SARS-CoV-2 infections. The infectious process will cause inflammations. One of the compounds that can be used to treat inflammatory diseases is taurocolic acid. Based on the research by Talabian et al., 2021 stated that TA can reduce the expressions of IL-1 alpha, IL-1 beta, and IL-6 induced in saliva of Brow 264.7 cells and has anti-inflammatory activity on gingival fibroblasts, carcinoma cells, human oral squamous cells, and macrophages by in vitro. Anguilla bicolor is a fish that is rich in nutritional content, but the other great potential possessed by this fish has not been widely exposed. So this study aims to see the potential of taurocolic acid obtained from Anguilla bicolor using molecular docking analysis. Here is a simple animation of how the SARS-CoV-2 and ACE2 attach with each other in human cells. The method itself consists of two major pathways, namely metabolomic analysis conducted by Kusumawati 2020 and molecular docking. The molecular docking consists of ligand and protein preparations, molecular docking, analysis and visualization of molecular docking result, and conclusion. Okay, this molecular docking uses two comparison variables, namely delapril and lisinopril. Both of these compounds are ACE inhibitors. Based on the result of the molecular docking, the binding free energy of the TA compounds was more positive than delapril and lisinopril, which was negative 6.3 kilocalorie per mole. When viewed based on the locations of the attachment, this TA compound is in the ACE2 binding pocket. The ACE2 binding pocket was determined based on the ACE2 amino acid residues that binds to the SARS-CoV-2 RBD. However, based on the molecular interactions that occur, the TA compound forms hydrogen bonds with two ACE2 amino acid residues, namely lysine 353 and arginine 393. This result indicates that there is spontaneous bond between the amino acids and the ligand compound on the binding sites of the receptor. The TA compound did not form hydrophobic interactions with ACE2. The presence of bonds that occur, both hydrogen bonds and hydrophobic interactions, contribute energy so that the bond affinity or the binding free energy becomes more negative. These molecular interactions is important to look at because if more amino acid residues are not present in the binding pocket, there will be a cytokine storm in severe cases due to the wrong ligand targeting the S2 receptor binding. There is also need for a thorough study of the secondary metabolites found in eel. The conclusion is based on the result of molecular docking. Taurocholic acid successfully binds two amino acids to the active site of ACE2. And the recommendations of this research is that further research is needed to determine whether taurocholic acid can play a role in inhibiting SARS-CoV-2 infections, considering that this compound has potential as an anti-inflammatory. That's all my presentation this time. Thank you for your attention. Good evening.